Hi, everybody. So this is going to be a presentation about managing complex UI using xState. So my name is Xavier. I did not write the library that I'm going to talk about, even though I go by X. That's a lot of questions. So I'm a staff software engineer at Jet, part of a customer experience team. That's what we call Batman. So I'm French. I've been here for longer, so maybe my accent is not showing as much, but I'm also a scuba diver and a jiu-jitsu student. And these are some of the contacts that you can use to reach out to me. I'll share those at the end of the presentation as well. So the agenda for today is, so my goal for this presentation is not so much to convince you that state machine is what you should be using moving forward. My goal really is to explain to you what a state machine is, what a state chart are, and how would you go to implement a state machine with xState. So we'll look over what the concept of state machine and state chart is. An example, we go over an example of a complex UI and how the xState moving parts are helping you configure that state machine. And we'll go over a demo together, and then if you have question and answer, I'll be glad to answer them after the talk or later on tonight. So what are state machines and what are state charts? So we talk about a finite state machine. I'm going to take an example of a traffic light. They are composed of a finite amount of states. For the case of a traffic light, you would have essentially green and yellow and a red light. And amongst how do you go from one state to the next is predefined by sequence transitions. And each transition are going to be triggered by events. So I don't know, a show of hands, who is familiar with like similar like Redux, event-based state management, or Redux, all this kind of stuff. Okay, so that sounds like very familiar, right? You have an event, trigger a transition, and then you compute your new state based on that. Now, with that in mind, let's go and look at what state charts are. And state charts were created by David Harrell in 1987, and therefore are nothing new. State chart is essentially an extension of what state machines are, in the sense that in your state machine, as we've seen before, every state was like green, red, and yellow was like basically a label for your machine. By state charts, each state itself can be itself another state machine. And even more, they can even be a state chart itself. So this is where you're starting to get some powerful abilities by just the way you go about composing your state chart and substate. Substate themselves, they can remain atomic, so one single state, or they can be compounding, in which case you would have additional state machines powering those states. And this is the advantage of what state charts are. This is where they find their strength. As you start using them, you realize that the way you compose allows you to do very crazy things and do crazy things, but in a manner that you control always. So in an example of a traffic light, what it looks like is that when I'm entering the red state, you have those pedestrian crossing, and essentially that pedestrian crossing signal can be powered by its own state machine. So when you enter the red state, you're actually initiating the substate machine to power the little pedestrian crossing. And the pedestrian crossing has its own state machine that goes from walk to wait to stop, and then exit that state. And you will resume being in the parent state machine. And you see that the event that triggers this transition of a pedestrian state machine is going to be the pedestrian time. So, all right, but why? And why this picture of a rover on Mars? So the reality is that state machine and state charts are what's powered like some of the most amazing innovation in computer science. And it's because of the ability for you to be very deterministic about how your system is supposed to operate. In the sense that it makes the impossible impossible. How many of you has been peppering the code with is loading, is done, is editing, maybe it's doing something, and it's all spread out across your code? You can find yourself, like, as your application is growing, discovering that you're creating impossible state that your user is reaching, and you're like, okay, how come these users trying to do this? It's not supposed to see that button, things like that. That's what these state machines are doing, because they're explicit. It makes the impossible impossible because you didn't create the impossible state to begin with. Finally, and we'll see what's very important as software engineers, like reading all these that are peppering your code makes it very difficult for you to intellectually visualize what the application is doing. And when you actually create that state chart to begin with, then it makes complete sense. It's very quick to grasp. So let's look at a complex UI example. This is an example from Material.io. Essentially, the user here is picking some files, and you can see as he's selecting, is going from a browsing state, selecting state from browsing state to a selecting state. And when he's unselecting the last item in the list, it goes back to the browsing state. So the browsing state essentially is this one, where you have the ability to perform certain actions, and you have like a very specific UI. One of these actions is actually to select an item. And when you select at least one item, you're entering the selecting state. Then on the selecting state, you saw that the UI is kind of changed, like, you know, some nice colors and whatnot. And also different sort of action where you could share the selection, move the selection to folder, delete the selection, unselect items, and so on. So now that I'm seeing this and I'm sitting with my product manager and my UX designer and whatnot, I go and I create my state chart. And so far, so good. I have a browsing state, selecting state, cool. I go from the browsing state to selecting state by selecting an item. So that triggers that transition from one state to the next. And then, as my user was doing, I'm selecting more items. So now we have like a catch, like we're actually looping over the same state because I'm continuing my selection. We'll see about how we do this, but this is called an implicit transition, meaning that you are not specifying another target. I'll go into the details of what this means in a little bit, because there's a catch why I'm saying you loop over the same state and not you're staying on the same state. And we'll look into why. Then the user was unselecting items. Selecting items is going to be either implicit or is going to be targeting a new state, and it's based on a condition whether or not it's the last item in the selection or not. Finally, resetting the selection will also prompt the transition from a selecting state to a browsing state. So far, so good. All right, but now I also want to delete selection. So entering asynchronous operation. How do I do this? Well, we all know that asynchronous operations are subjected to latency of the network, things happening on the server, and things like that. So we know that we have to enter deleting state. And this is where you're going to have like a little loader displayed and things happening in the background, et cetera, et cetera. From deleting, everything can be successful. Thumbs up, you go back to your browsing state, you're deleting your items, etc. However, it can also fail. So what do you do when you fail? When you don't think about it first and you do nothing about it, you don't handle errors. You know, we all been there. We all know what I'm talking about. So because I'm a good UI developer and I'm thinking about everything that my user does, I'm entering a prompting state. I want to prompt the user something happened, and maybe you want to retry. So in this case, I didn't do retry, but I might as well do it. Or I dismiss the prompt and I go back to my selecting state. So far, pretty good. I even addressed like the asynchronous operation. Awesome. So this is very much my global state chart, my final global state chart for my application. Let's move on and look at the xState itself. So xState is a library, JavaScript library that's been written by David Khorshid, and it's a JavaScript library. It's not a React library, meaning that you can use it with React, Vue, Angular, Ember, if you are like that. But essentially, you can use it for whichever JavaScript-powered application you would want. So if we go back to our global star chart, I want first to think about events. So the events, as we've seen, are all these little verbs, if you would say. Events are what cause the machine to transition from one state to the next. They are essentially composed of a type and a payload. Sounds familiar, right? Redux people? Awesome. And the payload is here because it's going to be handled to actions that are what you handle side effects with. Bear with me for a second, and we'll see about what actions are. But even so far, are looking like this: type and an optional payload. Now let's look about how I would go about creating a configuration for my machine. The state machine configuration is going to look like this. It's going to have 4 items. It's going to have first the key, which is going to allow you to reference between parent and children state machines. You're going to be able to reference each other. The second thing, you're going to have a context. So the context, so quick apart it. The state, when I'm talking about state machine, state in the context of xState, state is just a label that you put on your machine that tells you this is the mode in which you are evolving. It's different than the way you will look at state in a React context, where this is what the quantitative data that's powering your application and that you display to your user. In xState, that quantitative data is actually what you will store into your context. In this case, I'm setting it up to an initial app context, and we'll see a little bit more details of what it looks like. But this is where you would store your quantifiable data. Then you're going to actually need your state chart, which is composed of your state nodes, and each state node will look over the transition. And finally, the entry state. The entry state is going to be one of the state nodes that you specify. Here it's going to be browsing. Now let's look at the transition. So transition in our state chart are the arrows. And they are triggered by those verbs that are the events I was explaining. Let's look at more particularly the selecting state. So I'm going to visualize just the arrows are going away from my state. So it's going to be the delete selection, and this delete selection is going to the deleting state, if you remember. So to configure that transition, I'm going to specify that on the delete selection event, I'm going to target the deleting state. That's it. For the reset selection, I'm also going to do the same thing with the target, but on this case, I'm going to have a side effect, which is going to be configured by the action. Once again, I'll go into how this works shortly right after this. Then we have a select item. Remember the implicit transition? So implicit transition, you just don't specify a target, and there you go. You have your transition. It's done. Same thing, side effect. But now there's a more complex use case, which is the deselect item, and that's what we call a guarded transition. And the guarded transition essentially is going to be handled into an array. And the first is going to be the one that targets the back to the browsing state if it's the last item that you're unselecting. And the other case is going to be, if that's not the last item, then it's just an implicit transition, therefore no target. So now that we look at this is basically how I'm going to configure my state charts for the selecting node. Let's look at what those actions are. So as I was saying, actions are fire and forget side effects that are occurring when you are completing a transition. So therefore, in xState, there is 3 types of actions. The one that are occurring on entry. So when you are actually entering the state, those actions will be fired up. So in this case, we are loading the items. Maybe we do something asynchronous, and then we are triggering some analytics. You also have the ability to do it on exiting the state. Same thing here. I'm just triggering some analytics. Sounds familiar for people who are actually dealing with analytics? That's how you would go about them. And finally, the one that we've seen already, where the one that are triggered upon transition that are triggered by events. And that's that. So now if you go back to what I was explaining when you have implicit transition, well, an implicit transition will fire up those on entry or on exit every time you loop over yourself. So this is where it becomes a little bit interesting to understand the distinction between staying on a state node and actually exiting a state node and entering a state node instead. So what do you do with those actions? So I was explaining that you could do side effects, and the side effects sometimes are actually updating the context. And that's actually, let's look at what the context is. I was explaining earlier that the context here, we are going to set it up to the initial app context, which in my case is going to be just a series of items, and then an array that contains the selected item. For my items, it's just an array of objects. So as I was explaining before, the context essentially holds all the quantitative data that actually is going to be iterating your application moving forward. It represents basically the extended state. You have actually the ability to read the context of a parent of a children if you are composing your state machine this way. It iterates your application components, and you are updating it using action, as I was explaining. So how do you update the context, and what are the things to watch for? So in our app machine, you're going to define an object that contains all those actions. And if you remember, when I was selecting an item, I was actually triggering the side effect called add item to selection. So Redux people, again, we know that when we have a state, the state of application, it's highly recommended for us to never mutate that state. You always don't want to create a new state so that you can preserve history into your state, et cetera, et cetera. You never want to change those objects. You want to create new objects. And this is what the assign function is here to help you with. The assign function basically will preserve history. Here, in this case, it will create a new object that doesn't change the list of items, and that would just create a new array of a selected items array with the item that was passed to you from the event payload. So remember this event that was select item was add a payload of item. Here I have access to the context, which is the current context of my machine, and I have access to the event, and through the events I have access to the payload. And this is how you actually add an item to your selected item array. So essentially, we're going to do this for all our actions. And in this case, I'm updating the state, but you also have the opportunity to create actions that are like completely outside of your machine that might trigger like some API calls. And those are fire and forget. So you don't have control. You don't have any configuration with the callback. So what does it look like in React? And I'm going to look over this code sandbox. So in React, is this big enough? Good. All right. So I'm going to close this. Move the add. Better, or is it better? Excellent. So in React, what the great news is actually, I'm in the app machine here. Let me do that again. It's in the app.js. So in React, state machine, xState is coming up with the hooks. Use machine, yay! We love hooks. So this use machine is essentially going to handle the booting of the state machine. And here you'll see that the dev tool is actually accessible, which is pretty cool. And it gives you back the current state machine and the ability for you to send an event. So the current state machine is going to provide the context, and you will have access then to the items. And here I'm setting an item list. So I was kind of lazy, I did this way. But I'm setting up an item list for me to then display my the different components. And this is simply how you access it. Now, let's say I want to trigger actions. I would create event handlers, like the select item here, that would just use the send method and specify the type of action of event that I want to send. And here, I want to send the select item with the item here. Now, so this is pretty cool. This is what ultimately I can show you real quick with the dev tool. And shamelessly, they piggyback on Redux dev tool, right? Because why recreate something when you can use what others created for you? Here, you see that when I'm selecting an item, I have the type of select item, and I'm passing the item. And the state is going to change. If I look at the diff, I will see that here I added an element to the selected item array. Pretty cool. The other thing that is also very important is that you have ability to match, to use the matching. So current.matches is going to allow you to check whether or not this state machine is into a given state. So here, I want, for example, to go from one class to the other based on that state machine state. Cool. So this is basically how you're going to use your state machine in React. The rest is just the configuration that would be over. The cool thing that I was explaining before is that you have a bit visualize your state machine. So when I put this into a tool called xState Visualizer, that's what this looks like. Looks great, right? So maybe not, but essentially you have the ability to quickly view if your application is doing what it's supposed to do. And what's even better with a xState Visualizer is that you can simulate that here by clicking select item. I know that my target is going to be going to selecting. You have the ability to actually mimic how your application is going to go from one state to the next, and by just clicking around and making sure that the whole cycle is completed. So it's a very cool tool to use, and it's only going to get better. Right now, it might not be like super pretty and whatnot, but I can only imagine like the tooling that would be developed in the future to allow you to quickly put like state machine configuration into that tool so that the user can have that mental model immediately. So it's self-documented. It captures the complete picture. You have to think about it beforehand, but it's still self-documented this way. It's explicit. It's easy to understand because you have a visual representation of what your machine does. You also have the ability to test the behavior of your application independently from the presentation layer. Thanks to those events, those actions that are pure function, that makes it's very simple for you to implement unit tests around the core of your business logic. And they actually scale very well. Like you see in our light, your traffic light example, then if I want to add the pedestrian crossing, I just create a submachine to handle this use case. And because of things that we haven't seen in terms of a parallel states, compound states, compound machine, state machines, parallel state machines, you have the ability to compose your whole system to model your whole system using state machines, and to have like a robust system that's always doing what you design it to do and not anything else. And my personal recommendation is to consider state machines at first for things where you want your user to have a very predictable path from one end to the next. At Jet, it's particularly helpful for us through checkout process to avoid like those weird cases that we might be confronted with. But it's also on our retail lab that just opened in Leviton. It's used actually for the kiosk application. So as we develop richer application, those state machines actually allow us to have very robust system for user to use. Thank you.